Our project is about revamping sugarcane industry spendwash by physicochemical treatment under the guidance of Prabharajan, myself, Bharatam, and my teammates are Prasanayam and Vinod Kumar. Introduction: Wastewater is polluted from the wastewater polluted from the water graded from human and industrial activities. Nearly two-thirds of the population are affected by water scarcity. And sugarcane industry is the second largest agro-waste company for production of for taking the waste producing wastewater. In India, there are nearly 732 sugar industries, and it produces nearly 339 megatons of lakhs of wastewater. These wastewaters are contaminated in land, water, and air, so it contains a large amount of pollutions to that. Problem statement. In recent days, the sugar industry are not only involved in productions of sugar, but is also involved in production of ethanol distilleries, which takes nearly 2,000 liters of water for 1,100. For 1 liter of alcohol, there are nearly 170. It consumes 175 liter of water. This discharge contains BOD, COD, TDS, phosphate, and nitrates. These contaminants affect human beings, animals, plants, and aquatic animals. If we treated this water, it can be used for used in the company itself. Objective: the main objective of our project is to study the characteristics of sugar industry spent was to treat the wastewater using combined physiochemical treatment process analysis, the effect of pH, current intensity, contact time, and absorbent dosage to recover the wastage sludge produced after the electrocoagulation process. Methodology: we collected the sample, initial characterization are done, materials collection and experimental setups are done, electrochemical treatment, absorption process. These are the physiochemical treatment process. Result analysis, recovery of sludge. In recovery of sludge, we use the sludge for dye removal process and report preparation. This is the this is the initial water we collected from the sugarcane industry. These are the initial characterization. We done the characterization for color, pH, BOD, COD, dissolved oxygen, and chloride. We are doing physiochemical process based on the ratio of BOD by COD, which is less than 0.63. So we go with the physiochemical treatment.
Here, my batchmate has came up with the initial characterization, and I'm here to continue it. And here we choose an physiochemical method because of the BOD to COD method, and the physical chemical method is nothing but a combination of physical and chemical method. And physical method, we have come up with electrocoagulation, and chemical method is absorption process. Electrocoagulation is nothing but a process of giving a current to an electrode by which um, our organic components are removed using that, and it is a reactor which have used, and which has a DC meter and a reactor and an electrode, and connecting wires. And it is as a process it is a process which have we used, and we have studied based on the different volts of 10, 15, 20, 25 volts. And we taken a sample, so we taken each house, and we have sampled for, and we have test for COD, chloride, TDS, and pH, etc. And we have used an aluminum electrode because of the combination of low sludge. And but we have also used an hydrogen peroxide because due to the electrode degradation, we use hydrogen peroxide, where hydroxide is simulated using hydrogen peroxide. So for HO, uh, OH is very important factor for during an electrocoagulation process, which is used in a removal of organic components. And you can see the image where the formation of three layers, where sludge is forms, and treated water and flocks were formed. And you can see that images of three images were initial, and which and second image is EC treated, and another is a dosage of hydrogen peroxide. And you can see the dosage peroxide is where much color removed, and not only color also removed. All the characteristics such as COD, BOD, pH, chloride, and everything has been removed. And now we can see the comparison table, where in 15 volt we have made a much more maximum, and for due to the and for high renewable efficiency we have found for chemical treatment, that is absorption process. And the sludge we have obtained is collected by reactive filtration, and it is heated for 105 degrees for 12 hours, and it is used in removal of the absorbent. It is used as a removal of absorbent, and which is used in dye industries and removal of phosphates. And absorbent process is we just used organic and inorganic compounds, so we call it as hybrid composite, and which doesn't which have never been used in sugarcane industry spendwash. So, and we combine both, and we have stirred for 12 hours, and we have kept and heated for 24 hours, and we have a composite which is an titanium acetous and titanium dioxide composite, and it is a semi image. You can see titanium dioxide and acetous, which is disseminated very well. Um, and it is a process where we use two doses, where point 1 gram per 100 ml and 1 gram per 100 ml. At point 1 obtained much more removal efficiency compared to 1 gram, because due to its nanoparticle, 1 gram is much more in dosage, so we obtained the characteristics more, so we not able to. Yes, so we find out that point 1 gram is much more removal efficiency, and finally we have came up with that the COD removers up to 98.58 removal percentage removal efficiency, and this can be used for irrigations, and it can be again it can be used for the industry for reuse. Uh, yeah, thank you.